So we're going to cover two sections today. We'll have two sections of homework tonight. And it'll be super easy homework. Not a lot of work to show. Section 4 is titled Decimals and Conversions. We're going to, as I stated before, we have to know how to add, subtract, multiply, and divide fractions because of the thing I just shared on the board with you. But knowing how to add, subtract, multiply, and divide decimals is useless in algebra. We're just going to use a calculator all the time. But your calculator won't do certain things. And one of the things it won't do is identify place value. So I want you guys to be full participants today. I'm not, needing this knowledge for myself. I need you to show me that you understand it. So I'm going to ask questions. You guys participate. What place is the 3 in? Everybody, what place is the 3 in? Everybody. 3 is in the ones place. Okay? How about the 2 up there? What place is the 2 in? Everybody. Tens. What place is the 1 in? Everybody. Hundreds. What do each of these numbers end in? The letter what? S. S. So we come to this question right here. It says everything to the left of the decimal ends in what? S. Just put S there. Nice shoes, bro. Thanks. Okay? The decimal. When you're writing a check out of your checkbook, what word represents the decimal? Do you know?
No.
And. Very good. And. So whenever we're using the word and when it comes to decimals, it represents the decimals. We don't say $123. We say 123 and 46 100ths, okay? Because and represents the decimal. 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. What place is the 4 in? Quickly. Everybody. Tenths. Okay? Is there such a place as the oneths place? No. Which is kind of weird because then we have everything else repeating. Tens, tenths, hundreds, hundredths. But there's no oneths. Okay? There's no oneths. What is the 5 in? Quickly. Hundredths. You're writing all this down in your workbook. 6 is in the thousandths. 7 is in the 10,000ths. Okay, everybody, what's the 8 in? 1, 2, 3.
100,000.
That's right. Hundo. 100,000ths. What do all these end in? THS. So everything to the right of the decimal ends in THS. So this is one of the rare pages that actually was printed in color for you. You're probably like, why? Well, it's this little thing at the bottom here that we want to work with for a minute. Let's zoom in on that a bit. Okay? So there's a process by which we name numbers, or a pattern. It's called new name, tens, hundreds, repeat. New name, tens, hundreds, repeat. So think about this right here. We already identified on the other board there and up on our workbook that 1 is in the what place? What place is the 1 in? Hundreds. So if we keep moving to the left, the 0 then is in the new name. What's the new name? Thousands. Okay? And then we have tens of those, so 10,000s, and hundreds of those, 100,000s. And then we have another new name where the 3 is. What's the new name? Yeah, it's millions. And 2 is in the tens of them and hundreds of them. Then we have a new name. Billions, then 10 billions and 100 billions, and then a new name. Trillions, then tens and hundreds, right? And the same thing works in the opposite direction. So the 8, if we look at the 8, right, it was in the 100,000ths. Okay? So the 9 will be a new name. What is it? If that's the 100,000ths, what's that? Millionths. And that is the 10 millionths and the 100 millionths, and then this will be the billionths, new name, then tens and hundreds, and repeat on and on and on. Cool? Did you know that we have named lots and lots of numbers? There's quintillions, and there's just all kinds of different names and stuff. But we don't really know them because it's kind of like use it or lose it, right? We don't really use things past the trillions. I mean, the trillions are really just when you're talking about like national debt or stuff like that. But yeah, we don't really use too many of these other really massive numbers unless you start getting into like scientific distances between planets and, you know, all that kind of stuff. Okay? All right, let's go to the next page. So another thing that your calculators will not do all of for you, but some for you, is what we call conversions. Your calculator will complete some conversions from fractions to decimals and things like that if you plug it in correctly and understand how to do it, but it will not complete all the conversions that you need. So we have to know how to do conversions without the calculator. The first conversion that I want you to understand is the conversion from decimals to a fraction. So if I'm a decimal, what's the first decimal that's up there? 5.7, okay? So in the red box, and again, you can star the red boxes because the red boxes are things you need to memorize, but in the red box, it says the first thing to do is to locate or identify the last PV. What does PV stand for?
Place value.
Yeah, it was on the previous page. PV is going to be our shorthand for place value. So we're going to locate the last place value in each of these problems, and that is going to be the number farthest to the right. So what's the place value on the farthest right here?
7.
Well, 7's the number, but what's the place value? It's the tenths. Very good. So then you take that entire number without the decimal, 57, and you place it over that last place value, tenths or 10, and you're done. You've converted the decimal to a fraction. Now I get students sometimes, they say, well, isn't that 5 and 7/10? Wouldn't you write that? No, we said we don't like mixed numbers in algebra, so we're sticking with the whole improper fraction thing. Cool? That's why we're going to put the whole number, get rid of the decimal. That's why we say that. Or we would write 5 and 7/10. Let's do the next one. 4.0003. 4.0003. Okay? So what's the last place value? 10,000. It's very good. And if you're like me, I have to put my finger or my pencil here and I got to count tens, hundreds, thousands, 10,000s. So now I'm going to put 40,003 all over 10,000. And I'm done. I've converted that decimal to a fraction. Hard or easy? Hard or easy? Yeah, pretty easy. Okay? In your homework tonight, almost no work to show. So, I mean, you could, in essence, you could just hand me the answers back, but that would be wasting your time and cheating. But I'm saying, when you're not showing your work tonight, you don't need to be anxious. Like, oh man, Brother is going to dock me. I'm not showing any work. There's really no work to show. Okay? And the graders know that. Okay? I want you to do the next two on your own, 0.39 and 112.32. Do it. I'll write the answers on the board for you. You can check them. See if you did it right. Okay? Say woo if you got them right. Okay, super easy. The next conversion, it says it's one of our favorites. Well, screw that. It is my favorite. It's the easiest of all conversions to do because we can just divide on a calculator. There's a little smiley face there because it's kind of funny because we don't even really have to think. We just take it, we say, hey, 3/8, all fractions are division statements. And so 3/8 equals 3 divided by 8 on my calculator. You plug it in. What do you get?
0.375.
And you're done. Okay? Do the next two on your own. Is 13 over 33 0.39 repeating? Or 3/8? 3/9. And you can put a bar over that whole 3/9, right? Because it's 3/9, 3/9, 3/9, 3/9. Yeah? Say woo if you got those two right. Woo. Good. Question?
If you don't put the 0, is that wrong?
No.
So if you just put like the...
Yeah, if you put 0.39 bar, that's totally cool. And we talked about that maybe a couple days back, that the 0 is optional.
Yeah.
You know, it just, the 0 is there for clarity. Okay? All right, these next 5 right here, I want you to have these memorized, okay? You should be able to make these conversions back and forth without a calculator. What is the decimal version of 1/4? 0.25, write these down. 1/2? 0.5. 3/4? 0.75, right? And those are pretty easy because of our monetary system, quarters. We're pretty good with that stuff. How about 1/3? What's that? That's right. 0.33 repeating. Well, if 2/3 is twice 1/3, then what's twice 0.33 forever and ever? 0.66 forever and ever, right? Yes?
Can I just write it like 0.3 and put the repeating over the first 3?
Yeah, sure. Yeah, I'm cool with that. Yeah, it could be 0.3 or 0.6. Absolutely. I just did the extra one just to, I don't know. Again, clarity. You know, just trying to make sure everybody knows we're all good. Okay? Good stuff. All right, so the next thing in this section is rounding. You know what rounding is? It's what we do at Thanksgiving. You know, just gonna eat a lot, get a little rounder, you know, have to recommit to the gym. Rounding. Your calculator's not gonna round for you, okay? If you're asked to round something, you gotta know how to do it. The red box, it's there because it's there for everything we do. There's always a red box to explain what we do. But I gotta be honest with you, I don't know, the red box kind of reminds me on this process rounding, it's like tying your shoes. If somebody asks you to give them a 5-step process on how to tie your shoes, you'd be like, can I just show you? You know, it's like, it's hard to explain some things. It's just easier to do it. So rounding, right now, let's take this number 123.45678. 123.45678. They ask us first to round this to the nearest 10. Where's the tens place? What number's in the tens place?
4.
Tens place.
2.
2. Not the tenths, the tens. So sorry if I did not pronounce that properly, but yes, it is the tens. So it's the 2 right there, okay? And whenever we're rounding, we always look at the number to its right, and that is a 3. And so it says up there, all right, here it says locate the indicated place value. We did that. It was the 2. Then it says look at the number to its right. We did that. It's a 3. And then it tells us if it's in the 0 to 4 category, it's round down, and 5 to 9 is round up. Now, when we round down, here's my question for you. Does our place value go down or stay the same? It stays the same. When we round up, does it stay the same or go up? It goes up, right? It never goes down. It either stays the same if it's round down or goes up if it's round up. In essence, rounding is asking a simple question. In this instance, it's asking the question, is this number closer to 120 or is it closer to 130? What's the answer? That's closer to 120. So the answer is 120. And if you think about that, when you look at that number and it's in the round down category, our number stays the same. And this number turns into a 0 because it's to the left of the decimal, and all the numbers after the decimal, they go bye-bye. They wipe out. So let's do the next one. It says round to the nearest tenth. Now we're looking at the tenths. What number is that?
4.
It's the 4. So we look at the number to its right, and it's in the round up or down category? Up. So our number is going to what? It's going to go up. We're going to have 123.5, and all the other numbers drop off. Hard or easy? Feel good about rounding? Especially at Thanksgiving? Who likes to eat a lot at Thanksgiving? Raise your hand. Oh, I do. Oh, I do. Yeah. In my younger days, it made no difference. Now, I gained like 10 pounds in one weekend. I have to run a lot. A lot. In the snow out here in this godforsaken country we call Rexburg. You guys ready for winter? No, me neither, man. Who likes to ski or snowboard? Do I have any skiers or snowboarders in here? Really? Ooh. Well, if we get good snow before the semester ends, we will cancel class. Big powder days are more important than your learning. It's true. I will send out a message. Anytime after Thanksgiving, if there's a big powder day up there, I'll send out a message. And I'll say, we are canceling class today. I'll see you Monday or Wednesday or whatever. And for those of you who ski and snowboard, you'll know why. And if you want to ride up to Grand Targhee, you can call me. I'll be, yeah, jump in, man. We got space. Me and my boys. Okay, that is the end of this section. You see, it's easy. We're going to do another section, but before we do, I want to talk about your homework. So let's look at this. In numbers 1 through 8, we're doing conversions, just like we learned. But notice that from 9 on, we're adding, subtracting, multiplying, dividing decimals. And some of my students today were like, I thought you said you didn't care if we knew how to do that. No. I said, I don't care about doing that because it has no impact on algebra, but algebra problems will still have decimals in them and we'll still have to add, subtract, multiply, and divide them. So I don't care if you know how to do it without a calculator, but we got to still do it, okay? So you can do all these with a calculator. If you're super invested, let's say you're a early child development major who's going to teach like grade school or early education, stuff like that, and you want to remind yourself how to do this, you can go to the math lab, you can Google it, okay? You want to show all your work, you can, but I don't require it, and you don't need to feel any pressure. You can just do this all with a calculator. But I want to teach you something really fascinating, really interesting, really quick. So I've told you before that I own a business. And in my business, every day, we sell products. So maybe today, one of my team members sold or gave a bid to one of our customers for $1,000 for some stone, okay? But maybe they made, with their big fat thumb, a mistake and they added another zero there and it really should have been $100. So this customer calls up our competition and they say, well, we sell that for $100 and we lost the sale, okay? Because we made an error there, okay? Or maybe we bid something out at $2,000, okay? But really, okay, it's supposed to be $20,000 and we left a zero off. Well, guess what? We can't go back to our customer and tell them that was a joke. Because in many instances, our customers are giving those estimates to their own clients and trying to win a job. And when they win it and have been awarded that job, they've been awarded it based on their price. And so then I have to eat that $18,000 mistake. So my employees, they get rode hard about mathematical errors because they can't happen. They cost too much money to the company. Whoa! Did you see that? That was like a magic trick. Like shot to you. What happened? You're scared. It's okay. So, here's the deal. Everybody in my company knows there's a rule in our company. Anytime you make a calculation with a calculator, you have to do it 3 times. 3 times. You can never just plug it in once. You have to do it 3 times. So tonight, in this class, every time you plug this in, I want you to do it twice. Now hold on, think about that for a minute. Let's say you put in a calculation tonight and you get the answer 2.62. And then you put it in the second time and you get 2.62. You're done. You know the answer is. But let's say the second time you get 3.65. What are you going to do? You're going to plug it in a 3rd time. So now you know why in my company it's a 3-time rule. Okay? So the bottom line is you got to put it in twice, but if you don't get it right 2 times in a row, you got to put it in a 3rd time and see which one is being consistent. This is so important in your lives moving forward. This is the stuff on tests. You should never take a test and put something in a calculator 1 time. You should always put it in at least twice and double check yourself. Because think about the size of those buttons and the size of your fingers. It's called a fat finger mistake in business, okay? That's what it's called. It's called a fat finger mistake. And man, in my business, those mistakes can cost thousands of dollars. So all my people know you got to put every calculation in at least 3 times, okay? You guys, it's twice. I want you right now, I want you to put this calculation in your calculator, okay? Number 26. Do number 26, okay? Has the roll gone around?
Yeah, I have it.
Okay. Has anybody not signed today's attendance? Okay, thank you. Great shorts, bro. Great shoes.
Thanks.
I love seeing you guys in shorts. Makes me happy. Okay. So the answer to number 26 on the answer key is what?
6.25.
It's 0.16. So here's a question for you. If this equals 0.16 and that is the correct answer, did you enter it as 25 divided by 4 or did you do 4 divided by 25? Because this is what you were supposed to do. Who did it wrong? Raise your hand, be honest. Okay? You won't do it wrong again. That's why we do this, right? I told you, making mistakes is a good thing. The division bar translates into a calculator like this. This is correct. Don't do that, okay? Whenever you have a division bar, it goes in opposite the way it reads, okay? This is 4 divided by 25, not 25 divided
So
by
if
4.
it didn't have that bar underneath the 25, would it be 25 divided by 4?
Well, if we had 4 divided by 25 or 4 over 25, okay, we get it. But as soon as we do this thing here, where we put that little thing like that, then it just flips. If you go like this, it means the same thing. You know? Okay? Did I answer your question?
Yeah.
Yeah? Alright. All three of these mean the exact same thing. 4 divided by 25, 4 over 25, 25 into 4. Okay? Alright. The other thing you're starting to notice in your homework is what we call cumulative exercises. Right here, cumulative exercises. These are questions taken from previous sections to keep you skilled for the test. And they will tell you what sections they come from, but they are review questions so that as we're learning new material, you're staying adept at doing the old material from this chapter. These are never optional. These are part of your assignment. Only thing optional is extra credit, okay? All right, so we get out at 3, right? So we're going to take a little breather between these two sections here. And we're going to come to section 5 here in a minute. Actually, you know what? Keep rolling for just a second. Let's just finish this first page. What does the word per mean? P-E-R. Per. You know? For each. And what's interesting is in math, for each actually means what? Do you know? It means divided by. It means divided by. Think about division. Okay? If I brought a bunch of candy here today and I divided it amongst you, wouldn't I be giving an equal amount per each of you? Right? Per each. Yeah. Division is just equal sharing. That's all it is. So per means divided by. What does cent mean? Cent. What's a century?
100 years.
100 years. 1 cent, 1 penny, 1/100th of a dollar. What does cent mean?
100.
Means 100. Means 100. So percent means divided by 100. That's what it means. Divided by 100. Okay? That's what it means. And underneath it says what does per mean? Divided. And what does cent mean? 100. Okay? So the next 3 questions are just literally as simple as it gets. It's saying, literally translated, 50% means 50 divided by 100. And the divided by 100 is already on the board for you. So 27% means 27 divided by 100. 2.3% means 2.3 divided by 100. Okay? All right, the number 1 rule of percents is to convert. And that means that we don't work with percents as they stand. We always convert them to another thing. So we talked about conversions today in the previous section. And really, on the first day of class, we said math was the manipulation of numbers to look different but remain the same. And I used the example of, I used the example of 0.5 equals 1/2 equals 50%. So here we have a decimal, and here we have a fraction, and here we have a percent. Well, we can go back and forth. We can convert this and call it that. We can go from this to this. We can go from, this back to this, etc., etc. So when it comes to percents, we always convert these. And the most common conversion is just making percents equal decimals, and then we'll work with them as decimals. So that's where our next page or two are going to guide us. before we get into that, I wanna just really quick here. I want to talk to you guys about some interesting stuff. So last time we met, I asked you, how do we get better at something? You remember that conversation? What did we say? How do we get better at something? What do we got to do?
Do something different.
Got to do something different. How many people in here, by raise of hands, how many people in here want to be successful? Raise your hand if you want to be successful. Okay. All right. So who doesn't want to be successful? Raise your hand if you don't want to be successful. You want to be a loser. Nobody wants to be a loser? I'm so surprised. Yeah, I mean, asking people who wants to be successful is like asking what the least common factor is of any set of numbers. What's the least common factor of any set of numbers? One, right? Everybody says they want to be successful. Everybody. Nobody says, I want to be a loser today and every day. Nobody, okay? You can pause if you want. Percent, and I want to become a decimal, or if I'm a decimal and I want to become a percent, these are the two processes. They're opposites. I have to move the decimal 2 places to the left or 2 places to the right. I have to lose the percent sign or add a percent sign. So here we have 27%. 27% doesn't want to be a percent anymore. Just wants to be in its decimal format, okay? Well, where's the decimal right now? Where's the decimal right now?
In front of the 2.
It's where?
Wait.
It's after the 7. It's right here. Agreed? Okay? So we're going to move this decimal. Now, hey, if I'm a percent and I don't want to be a percent anymore, I want to get as far away from the percent sign as I can. So if you don't remember move left, move right, think about it in common sense terms. I don't want to be this anymore. Get away from it. Move away. 1, 2. This is 0.27. You get rid of the percent sign. Hard or easy? Super easy. Okay? 23.1%. Quickly. Let's do it. 23.1%. Okay? Decimal. Move 2 places to the left. Run away. And we have 0.231. Get rid of the percent sign. Okay? 320%. 320%. All right? Where's the decimal? After the 0. 1, 2. This is 3.2. Hard or easy? So easy. Okay? You got this. All right? Okay. Help me really quick. I'm going to do this one with you on the board here, like just up here. I want you guys to write it. This is a percent. Here's a decimal. We move them to the right or to the left?
Left.
How many places? 1, 2. So what's the answer? 0.0023. Right here. Move it to the left or the right?
Left.
1, 2. So what do I have? 0.025. Okay. All right. Opposite over here. If I'm not a percent and I want you to communicate me as a percent, and I'm the number 2, right now, where's the decimal?
Behind it.
It's right here. Now, if you want to be something, you go towards it. Agreed? You want to be like something, you move closer to it. The percent sign's always at the end. So we're going to move this decimal towards the percent, and this becomes 200%. Okay? The number 2 is 200%. 0.56. What is it?
56%.
56%. Absolutely. 56%. Hey, listen, what place value is the 6 in to begin with? Hundredths. 56 hundredths. Percent means divided by 100. All makes sense. Okay? Next one. Is that 2.5?
Yeah.
Or is it 25? Oh, is it 25? 25. Okay? Decimal's right here. Move 2 places. I got 2,500%. Okay? All right, let's do these with each other real quick. Look at this. To the right or to the left? Oh. To the right or to the left?
Right.
To the right. Okay? So what's this one going to become?
62%.
62.3%. Move it 2 places. 1, 2. What is that?
230.
230%. This one. 1, 2. 0.6%. Very good. All right, let's go to the next page. Our last one, and we'll get out of here. Last conversions today. Decimal to a fraction, percent to a fraction. 27%. Again, here we go. 27%. And I want this to become a fraction. All right? Well, what does percent mean? Divided by what? 100. So this is 27 over 100. Done. The percent is now a fraction. Hard or easy? Oh, super easy. Okay, next one, 40%. What is it? Yeah, it's 40 over 100. Now, can we reduce that fraction?
Yeah.
Oh, for sure. And it reduces to 2/5. Now, if the book answer does that, you know how to do it. If it doesn't, just leave it and don't reduce it, okay? Now, what about, and I'm not going to explain how we got to 2/5 because you know how to do that. But then we get into this weird one here, two of them, 28.5% and 5.27%. 5.27%. All right, check it out. This is going to end up being 28.5 over 100, and this is going to end up being 5.27 over 100. And down here, we're asking you, how do we handle these? And there's this weird question here, is there such a thing as a fresimal? So if a fraction and a decimal got together and made a baby, it would be called a fresimal, okay? And that's what we have right here. These are fresimals. And there really is no such thing. You look up the word fresimal in a math book, it does not exist. So we can't accept this as a final answer. Now they wanted our answer to be a what? It's a percent to a, okay, so we got to get rid of that decimal. So the way we get rid of that decimal is with the big 1 rule. What place value is the 5 in? It's in the tens. Can I multiply that by 10 and it will move over one place? But what I do to the top, I got to do to the bottom because I can multiply anything by the big 1 and it remains the same. So this ends up being 285 over 1,000. Because if I move this over one place and that over one place, that's how that works. So some of you learn the rule to move it over a place, but the reason you can move it over a place is because of this. So what place value is the 7 in here? 100. So what are you going to multiply the top and bottom by? 100 over 100. Well, that's going to give you 527 over 10,000. And that's the answer to those, okay? And that's how you handle those. Because it says, how do we handle it? On the opposite side, a fraction to a percent. These are pretty easy because they relate to stuff we've already done. So take the first one. Is that 3/8? 5/8. 5 over 8. So a fraction to a percent is a two-step process. First we go fraction to decimal, and then we go decimal to percent. So how do I make that fraction a decimal? Well, it's my favorite one. Remember, we divided on a calculator. So this equals 5 divided by 8 on a calculator, which makes 0.625. Now, how do I take that decimal and make it a percent?
Move it over to
2 places. We just learned that. Yeah, we moved over 1, 2, and that equals 62.5%. That's how you handle these. So we can go to the next one, 12 over 5 real quick. We divide that, we get 2.4. We move it 2 places, it equals 240%. Go to the next one, we got 99.4 over 100. Okay? I put that one up there to mess with your minds. Okay? You divide it on a calculator, do all that stuff, you're wasting your time. Because divided by 100 means what? What's divided by 100 mean?
Percent.
It means percent. So doesn't that just equal 99.4%? Because divided by 100% means the same thing. Okay? And then the last one, 1/6. How about you guys do that really quick? 1/6 equals 1 divided by 6, which equals what?
1.6 repeated. Or
Say it louder.
0.16 repeated.
Yep. Okay? And so here's what I want to show you. This is one of the reasons that I do this. 0.1616, and I put the bar over it. So now if I move this over, I have 16.16%, right? All right, guys, that's your homework for tonight. Super easy stuff. Not a lot of work to show. Hey, keep working. Keep trudging on the road to success. And let's talk about that devotional story on Wednesday because it has a lot of sway with what you're going to be doing the rest of the semester. Okay? You guys have a good one. I'll see you Wednesday.